Hi everybody, welcome back. So let's just do a quick update on where we are with this, because I am extraordinarily busy this last couple of weeks and probably for the next 2 weeks. So I only have very limited time to work on this on and off. So every time I come back to the bench, I have to kind of remember where I left off, catch up, and continue on from there. So I was able to obtain some MCUs, and the one that I put in there is a TMP 80C49 instead of a 39. And really the only difference between the 39 and the 49 is that the 49 has something similar to this, some programmable memory, a PROM, built into the chip. And if I pull a pin, I believe either low or high, I can't remember, I think you pull it low, it'll use the internal memory, which you can program. Or if you pull that pin high, I think it's the ALE pin, don't quote me on that, some of you know these better than I do without looking it up, it will access the external ROM. So this is just configured to access the external ROM because that pin is pulled high on this board. So that's all that is. It works fine, and as you can see now, I turn the unit on, I do the open calibration, and it works, but we still have some problems, and we'll get into those later on here. But if I try to do the shorts test, it's similar to what it was, but then it flashes error 4 now. And that is because that's an out of range error, and it means that it's thinking that the leads or the connections or something are either too high or too low of a value. And quite honestly, if you put a resistor or open this up, it knows. So the circuit is working, it's just not working correctly. However, that does not inhibit the capacitor value from working properly. As a matter of fact, most of this is working correctly. So here's our 1500 picofarad cap that we were using in earlier videos, and if I hit capacitor value 1501, is that close enough for you? And if we move to I measured this very accurately on a couple pieces of test equipment. This is 1.227, I think, microfarads. 1.222. That's pretty close, I think. Here's a 470 microfarad, and it's pretty close to what it should be when I measured it. 474, 475, that's very good. Here is a 2200 that I measured to be 2153 on other test equipment. Again, this other test equipment was kind of proven to be very accurate, so I have a couple different things that I use. And you can see it's 2050, so it's off by about 50 microfarads, 50 to 100 microfarads. Not bad. And again, that's within tolerance. Now, the issue comes, all of the voltages are correct. If I do the capacitor leakage, let's say this is, for instance, this is a 16 volt capacitor, so if I just dial in 15 volts and I connect this up to the leads and I hit capacitor leakage, it doesn't really give you anything if I do ohms. If I do the current, it does read current. It's not correct, but it reads. And you can move the adjustment a little bit. So we still have to work on the leakage, and the ESR is the biggest problem right now. If I do dielectric absorption, so we connect this up, and I hit dielectric absorption, it goes through its little test. You can see it switches through the different current sources, and it says this is 8%. Okay, so that works. But anything in the resistance section is not working. Now, I found out a couple of interesting things while working on this. First of all, most of the signals on this are pulsed because they're driven by the MCU. So you can't just use a meter or something in most cases. Everything's pulsed. You have to sometimes use 2 channels on your scope, or more appropriately use a logic analyzer, which I haven't done yet. But to get the point, when this thing does, for instance, the leakage test or the ESR test, it will strobe through these different resistance ranges. It will clear itself with this MOSFET right here by pulsing it, and you can see right here there is all of the references for the leakage current to voltage converter circuit. The reference ground is actually tied through this L4 relay, and that goes out to the common lead of your probe. And what it'll do is, during the test at some point, it'll open this for a second and then close it. Same thing with this. This will run you through the different ranges. You can see how, and there's 3 different resistors that are precision resistors, 10 ohm, 100 ohm, and 1.1K. And that drives this signal, which you null out during the calibration procedure. And all of this is somewhat working how it should. It's very hard to troubleshoot because it's very hard to know. The description of function doesn't talk about how a lot of this works. And for instance, this 5.1 volt Zener, it's not to make it a 5.1 volt power source here. It's to clamp it at 5.1 volts so it can't exceed that. This voltage is actually controlled by this not being turned on, and by these, depending on which one of these is selected and how they're calibrated. So that voltage can vary. Also, this circuit right here, these 4066s are bilateral switches. So what they can do is they can take that reference voltage that is being created up here and switch them through to the inputs of these 2 voltage followers. So this takes your high impedance input and drives a low impedance output, and then that drives all of this, and it goes up into here, which goes to our A to D converter and all that. But all this happens in a timed sequence. And from what I can see, that's all working. So there's something wrong in this converter circuit, and that's where I am with the troubleshooting process right now. Everything is working well other than that. So it's just going to be one thing I'm going to find, and it's going to take care of it. But along the way, I've noticed a couple other things, and I want to share those before I close out this video. So if you recall, the first thing that I found with this was that there was a bad 74C374, and this is a flip-flop. It's actually a multiple flip-flops in one chip, and that can be seen right here, IC11 and IC12 and IC19, wherever it is here. So 11, 12, and 19, those are right here. And actually, during the process of testing all this and so forth, I went through a couple of these chips. And if you recall, this was an original problem when this thing came on the bench. Now, we don't really know what all the previous service technician did to this while he was in the process of troubleshooting it, because unfortunately, as we discussed earlier, he passed away during the COVID pandemic, and he was in the process of working on this. So we will never know, what state this was in when he was last worked on it. So that was a little bit of a challenge, kind of unraveling some of that as well. Now, what I found doesn't make a lot of sense to me. The outputs of these are MOSFET outputs. They're FET outputs. And at least from what I could see in the data sheets for this, because they do give you, some of the data sheets will give you a little bit of a equivalent circuit drawing, and in the equivalent drawing they just show a direct output from a MOSFET. And if you look at these signals from all of these coils of these relays are directly being driven by IC11. And I have a feeling if you click those back and forth too many times, too rapidly, the back EMF from these little relays, because they have no freewheel diode on them, these two do, this one here and this one here, but these smaller ones do not. And I have a feeling that these are what's causing a lot of the failure problems with IC11. Hence, you can see where I've fitted these 1N4148s on each one of these. I marked the positive lead of the coil so I could properly polarize the diodes on there, and I put them on there. And I have not lost one of these chips since I've done that. So I'm not saying for you to go out and do that to yours, but that was one thing that I found that seems to have corrected that issue. These are all toggling properly now, and the signals going through them are correct. So at least from what I can see, or from what I can figure out. In addition, some of these null points that you do in the calibration, we'll talk about that in another video. You have to set these to like a null point. This one here on IC44 and IC43. And the one, which is this pot right here, is very, very sensitive. In addition to that, if the pot is the least bit noisy, it makes it really hard, and this has to do with your the dielectric absorption and the leakage calibration, or the ESR and the leakage calibration. And so in order to get this to be a little easier to adjust, I had to remove the old 100K pot from here, and I installed this 10-turn 100K pot. It made it a lot easier to calibrate. Most of the pots that are used in here, these controls, really are okay being a one-turn pot, because the adjustment range that those pots have is so small that you really don't have to move it that precisely. It's from one end to the other of the pot, you're only adjusting it a slight amount, so it's already close as it is. So, but it was just this one right here was kind of an exception I found, so I put that in to make that easier. All of the contacts are clean. All the probe, I ohmed out these leads using my Kelvin leads on this, and the probe is fine. There's nothing wrong with it. I measured the test leads, all of the connections, they're all good. But that error 4 is still saying that sense circuit is sensing that when we do the shorts test, or the short calibration, short leads for the zeroing, is still out of range, and we have to figure that out. And that's kind of where I am with it right now. But I have some confidence, at least now, that this will be repaired. I will be able to get the whole thing working now. We're kind of getting to that point. Now, a lot of you made a lot of really good suggestions, and I took some of your advice, and some, I have a few questions about yet. I did put in those JPAD 20s in here, and yes, they have a much lower forward current limit, their maximum rating, but they were working for okay, at the moment. I do have the proper ones fitted right now, and again, I don't like paralleling diodes like that for current, but they've done it. It worked before. It has to work again. All this seems to be working because, as you could see, we are able to test the different values of the capacitors and so forth. But the way these work in conjunction with this circuit, we still have a problem in between there somewhere. and I'm going to have to troubleshoot that and find it. What else did I want to say? Oh yeah, so these two transistors, TR40 and TR41, these FETs, they set the upper and lower current limits, and they pulse. You know, all of these pulse from the MCU, and that's all working now correctly. And they do toggle without any noise now once I put this new MCU in there. And I don't know. I know a lot of discussion has gone on, but you know, remember my early comments. I've just never seen these fail. They just don't fail. But then I had a viewer who said he's had 2 of them fail where he had to replace it. And then I had a lot of more viewers come on and say, look, the type of problem that this behavior doesn't indicate that this is the cause of it. I don't know. I know I replaced this and I was able to calibrate it. I really didn't do anything else in here. I will say, though, I did get tripped up a little bit because it worked a couple times and then started not working again. And it turned out that IC11 crapped out on me again and I had to replace it. And it was at that point in time I got kind of sidetracked and found out about these relays. And it took me back to, like I said, my little mod there. And I don't know if that's right or not. You also notice that R159, that's supposed to be a 15 ohm precision resistor, which is what I have now. The one that was in there was reading 25 ohms, and that was throwing some things off too. But again, it didn't affect our original problem yet, because I hadn't gotten to that point. So that has been replaced. I have a proper, what was it, 19.2 or 16.9K. I do have a correct one I got in. So I did order a couple of parts. And that's where it is. That's where we are. So I know some of you are going to be disappointed because I'm not giving you much more material on this, but I literally do not have the time right now. And like I said, I will try to interact with some of you in the comments as I have time in the morning before I go to work or whatever I'm doing. And I just wanted to get this up there to show you all where I am, and that we are to a point now where I think I'm seeing some light at the end of the tunnel, and it's fortunately doesn't look to be a freight train. So we'll get more into what all this is. This is really kind of cool how they do things, and we'll do that on a later video. And maybe we'll go through some of the calibration once I know that the calibration is working. It's because it's not right now how it should. So that's it for now. And until next time I see you, I wish you all peace, joy, happiness, and good health in your lives. And we'll be back, as soon as I get some time. I have 3 other really nice pieces of audio gear that I'm very excited to work on. It's coming up when we get this off the bench, so I really do want to finish this and get it out of here. But that's going to just have to wait till later. Just too much going on right now. You know how it is. Life gets busy sometimes. So anyway, take care, everybody. We'll see you again real soon, and more to come.